Hello, everyone. Let's wait for a little bit. Hello, everyone. Welcome to Chat Loop Backoff, where we dive into the code behind Cloud Native. I'm Iris Durmishi, and I'm a CNCF ambassador and a senior observability engineer at Miro. I'll be your host today. It's my first time, so please forgive me for any boo-boos. Every week, we bring a new set of presenters to showcase how to work with cloud native technology. They will build things, they will break things, and they will answer your questions. In today's session, I'm stoked to introduce Faika Ansari, who will be speaking about WASM Edge. And don't forget, this is an official live stream of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in the violation of the Code of Conduct. Basically, please be respectful to one another and to your fellow participants and also the presenter. With that, I will hand it over to Faika for today's presentation. And don't you worry, I'm going to be monitoring all the comments. So if you have any questions, we will have around 10 minutes, maybe a bit more at the end to answer them all. Faika, the stage is to you.
Hi everyone. Thank you so much, Iris, for the introduction. I'm Faika Ansari, and I'm a software engineer at Aquidi, the company which is founded by the creators of Argo CD, where I primarily work on Cargo, which is an open source progressive delivery tool that sort of helps manage software releases across multiple environments in a very GitOps friendly way. And I've been contributing to a lot of CNCF projects for a while now, and I sometimes maintain a few projects here and there. And I am a CNCF ambassador and a big fan of all things cloud native. So I assume most of you all know what Chat Loop Backoff is all about. It's not your usually polished or pre-planned deep dive. Instead, it's more like jumping into the project for the first time and fumbling around, figuring things out live, and hopefully having some fun along the way. So I hope you all are able to see my screen. If not, I will quickly share my screen. Yeah, there we go. So so today, for today's Chat Loop Backoff, I will be experimenting WASM Edge. So I never really had the chance to check it out before, but I do know sort of like it's gaining a lot of traction in the cloud native space, and WebAssembly in itself, like WASM in itself, is super exciting right now because it is super lightweight, portable, secure, and something. These are the things I've always heard about it at KubeCons and several conferences, and it has the power to sort of change the way we run our workloads at the edge in Kubernetes. So I figured out why not explore it together. So let's first, whenever I want to start something, I generally, I just try to swing around and get a wing with it by going to the website directly. So here we are on CNCF's WASM Edge Runtime website, where you can find the project's website. I think my screen is visible. Yeah, it is. Cool. So I'll probably just try to see what the project has and skim through the documents and figure out what exactly WASM Edge is. So bringing the cloud native serverless application paradigms to edge computing. Yeah, that's pretty high level. It's a light level, high performance, extensible thing, which is what we've been always listening about WASM Edge. And it seems we also have a very easy way to install WASM Edge with one line command. So, and we can create an application. Compared with Linux containers, WASM Edge can be 100x faster at startup and 20% faster at runtime. So now I know why WASM Edge is the talk of the day, because it makes things 100x faster and faster. At WASM Edge, you could take 1 out of 100 of the size of a similar Linux container application. That comes with high performance, WASI-like extensions. So it has network sockets, async processing, TensorFlow, inference, keys, value stores, and database connectors. These sounds exciting. It also comes with JavaScript support, has cloud native management and orchestration, cross-platform support, easy extensibility. Oh, that's a lot of things to talk about at once. But just because we're trying to explore and just to get a quick idea of what it does and what are the main features, I think this was a good read. It provides a lightweight, fast, safe, portable alternative to Linux containers in cloud native. Oh, I think these are the list of projects that are sort of using it, perhaps. And okay, we're at the end of the documentation. What I would rather do instead of getting started directly from here is quickly skim through the GitHub page, because that makes it easier for me in general to sort of aggregate all the documents that I have and then jump to what I want to run next. So Bosom Edge, it has 9.1 thousand stars, which is a lot, and which says it all about the trend that we have going out there about Bosom Edge. Okay, so there are 189 computers. Bosom Edge is the easiest and fastest ways to run LLMs on your own devices. It is lightweight, high performance, and extensible WebAssembly runtime. Okay. Quick start guides. So we have a lot of quick start guides here. I think this is the thing I love about GitHub, is it provides a lot of things at one place. So we have a quick start guide where we can check how we install Bosom Edge, and this looks like a pretty good documentation. Build and contribute to Bosom Edge, run a standalone Bosom Edge through JavaScript. Okay, I think we've already seen the introduction. Oh. It gets on run code. So these are a couple of information about how we go on to contributing. I think we can simply jump on to the getting started guide, where we see how we get started with Bosom Edge. So we have read this a couple of times, and my idea of Bosom Edge up till now is still vague, I think. We will cover the following content: install Bosom Edge, getting started, introducing Bosom Edge runtime, usages. Okay, let's just jump into seeing what it looks like. You can install the Bosom Edge runtime on any generic Linux and operating system if you use this. So I am right now on Mac OS. Please install Bosom Edge to run. The your system can get a git and curl. So if you have a curl, we can simply use this command. So I will try to find my terminal. Okay. Some benchmaster utilities and using Python. Okay, I think this would take quite time. So we're gonna try installing Bosom Edge and then see where we get from it. Getting started with Bosom Edge, quick start on Linux, Docker, and Red Hat. I would probably go with Docker. This is the prerequisites. Oh, we have Bosom Edge installed now. Let's quickly check the next steps. No, so the Bosom Edge plugin is all about this. So I think the current idea that I have of Bosom Edge, by reading about Bosom Edge so many times in these documentation, is it starts quickly, it uses less memory, and it works well with a lot of languages like Go, Rust, and all these things, is what is clear from these stuff. So we have run this one-line command, and now let's try to see. I think it's installed as well, and we should probably see how we create an application or function for Bosom Edge in Go, because that's sort of my favorite language. Oh wow, so I see a TinyGo example here, develop WASM apps in Go. In this chapter, we will learn how to create WASM apps in Go. And we're talking about TinyGo. So TinyGo is something really exciting, and it always excites me because I think it's something similar, because TinyGo is like a lightweight version of Go, which specially is made for small devices and low power systems. So if you all code in Go language, you all know what Go is, and TinyGo just makes it much better. So Go programs need a lot of memory, but TinyGo on the other hand makes it much smaller, and so much small that you can also use it on microcontrollers. So last time when I was at GoForCon, we actually used it in microcontroller. We were using it. We can use it in IoT devices, and today I learned we can also use it in WebAssembly for, I think, running our code in the browsers. So I think we should try this out. There are also other ways to develop WASM apps here, like in Rust, in JavaScript, C++, and Python. I'm not sure what I installed. Okay, we use the Python library to install WASM Edge. Seems I'll go with the using TinyGo to develop my first WASM application. And the best way to run Go programs in WASM Edge is to compile Go source code to WebAssembly using TinyGo. In this article, we will show you how to do this. So the Golang is adding WASI support. Stay tuned. It seems like the Golang does not have the WASI support yet, but TinyGo does. And TinyGo is also your way to go for microcontrollers. So it's going to be fun. I think we'll have to first install TinyGo. I'm afraid I already have it. So I'll just copy the link. You must have a Go already on your machine. Go version is recommended for Ubuntu and these stuff. Let's just try this. It seems very exciting to me, and I'm very excited to see what it will do for us. Okay, it seems that we just did. I don't have these commands, so is it for? I need wget. Not sure if wget works for Mac. I'll have to probably install TinyGo using Blue. Okay, cool. So we are going to use Blue tap TinyGo and Blue install. I think we'll quickly get this done because it's more about TinyGo than WASM Edge. Where are we? Yeah. So I think we're trying to install TinyGo, and then we'll check if TinyGo is working or not. I hope this is working. Yeah. Oh, we already had it here. Mac M2 alternative installation. Oh, and then we will have to use Visual Studio Code, it seems. Awesome. So now let's check the TinyGo version if it is installed properly. I think great. So TinyGo, we have installed TinyGo, and now let's create the simple Go application that has a main function to print a message to the console and see the magic of WASM Edge. I will have to create a file, and I would use Golang for that. Okay. I'll use a main.go file. And what does it say? You just need a Go app that has a main function to print this. We'll use this function and outside main function, you can use Go standard API to read, write files and access command line arguments and environment. So we can simply perhaps do this and see how things work. Hello world, compile and build. We'll compile the main Go program using TinyGo, and I'm going to go ahead and do that. And we have our binary in WASM. So I think the command line tool was simple. It was building hello.wasm target as WASI. So we're using WASI, which is basically creating application using WASM. We don't yet have support for Go, which is what was written here. Golang is adding WASI support, stay tuned. But TinyGo does have it, so we're using TinyGo. Cool. So hello world compiled and built. We have compiled the software. You'll see a hello WASM file in the same directory. Yes, we do. And let's run it. Okay, I'll just probably split screen so that it's easier for us to go through the documentation and also run stuff side by side.
Hey, it's looking like your terminal is not showing on the screen.
Oh, okay. Thanks for letting me know. The first. Thank you so much for letting me know. I thought this whole time I was sharing my whole screen. Okay, I think now things are pretty visible. Yeah. So, cool. Awesome. So this is my terminal, and this whole time I was coding on Goland. So this is the package that I've just right now added. This is wasm folder, and we have main.go. I ran the command tinygo build hello.wasm, and using the WASI support, and this created a binary that is hello.wasm. That's what we have done by now. And what is the next step? So you will see a hello.wasm file in the same directory. Yes, we do. And next, we will just run it using wasm CLI. So I hope you've installed wasm CLI. If we can just quickly check. Yes, we do have it. Awesome. I'll use wasm hello.wasm. And let's go. It's working. So hello TinyGo from wasm. Now this was a pretty simple function. The second example is Go function that takes a call parameter to compute Fibonacci number. However, for the Go application to set up a proper access to the OS, example to access command line arguments, you must include an empty main function in the source code. So they want us to try a different application, and I would want to see how it works. This is running a Fibonacci number, and the simple application compiles and run this. Okay, we have a Fibonacci.wasm, and now I'm going to simply... Okay, now we're going to use wasm reactor Fibonacci.wasm fib and then... Okay, let's see what it does. And then we'll probably take help of the help command to see what it does. Okay. Oh, there's an error. You can run it. Okay, so the documentation probably needs a fix here. We need to pass. The function needs an integer. It's running a Fibonacci number. Oh, awesome. So when you run wasm with the reactor flag and the binary, it gives you the answer, basically the response to this. And what does the reactor does? So I'm gonna just check if there's a help command, and of course use the grep key because that helps me always to search the things. Of course, so the reactor enables the reactor mode, and this reactor mode calls the initialize if it is exported. But what is initialize? There's not much information here. I might probably... There's not more information. WASM Edge Reactor. Let's see if we find some information on CLI guide. So the WASM Edge CLI has these stuff. Is there something about the reactor? Enable the reactor mode. Okay, so in the reactor mode, WASM Edge runs a specified function exported by the WebAssembly program. WASM Edge will execute the function whose name should be given in the argument 0. All right, and if an exported function names initialize, okay, the function will be executed with the empty parameter at first. Oh, so it seems like the reactor mode is enabling a special way of running WebAssembly modules where they don't run automatically on starting and they wait for the function calls from the host. That's pretty much what I can understand from this. There are a lot of optional things that comes here, and reactor is also one of which. In the reactor mode, WASM Edge runs the specified function exported by the WebAssembly program. And if the exported function names initialize, the function will be executed with the empty parameters at first. So it seems like the initialize function is a special function in WebAssembly, which would probably setting up the module before it starts handling requests. So what this document says is that if initialize is exported in the WASM module, WASM will call it when the module loads. So this is probably very useful for preparing things like memory and global variables and all those things which are used during the startup project before actually running the main function. This is something we generally do also in TinyGo. Is probably something that we are using here in WASM Edge and is a reason why WASM Edge is so faster. Resource limitation, these are the other flags. Okay, that's cool. So we went through running WASM Edge and this looks good. It compiled, it built, and I think it was fast. But I don't think so this is much of an information for us to judge if it was fast or not. But improving performance. So to achieve native Go performance for these applications, you could use the WASM Edge compile command. Cool. To AOT compile the WASM Edge, then run it in the WASM Edge command. Okay. So it talks about a different thing that you can use the compile command. So you could use the compile command to AOT the compile and WASM Edge command, then run it with the WASM Edge. Okay. So I'll use this command and on my terminal. And let's see what it does. We'll obviously build things together. Okay, so it compiled, it verified, it optimized the starting, then optimization was done. It also ran code gen. So what code gen is something, it's also something that we often use in Cargo and in a lot of projects that I've been contributing to. So code gen is like code generation, which means automatically creating the code instead of writing it manually. So I think compile is doing something similar. It's usually done by compilers or tools or frameworks which make development faster and also sort of reduces a lot of errors. So code generation is one of the coolest thing to automate coding. And in compilers, when you write Go code, the compiler generates these machine code and then the CPU can simply understand it. And in Kubernetes, I have seen tools like KubeBuilder and Controller Gen, which also if auto-generates the boilerplate code and CRDs and deep copy functions, etc. So there are a lot of examples of similar code generation tools. And from here, I think in WebAssembly or in TinyGo, it is converting this Go code probably into a WASM bytecode or something like that sort of, so that we can run it in the WASM assembly runtime. So basically code gen help developers to automatically produce repetitive or low level code. So that's what it is doing here when we use the WASM Edge compile command. It's starting code gen, then the output started, code gen was done, the output was started again, and then the output was done. Oh god, this is so cool. The logs are really cool. It helped me understand what the compile command actually does. And this was how it compiles stuff. So to achieve Go performance, I think we should use WASM edge compile command is what I can understand from this. And it was pretty much clear to me what it did. Now let's see what it wants us to do is basically run the hello WASM stuff. And yeah, that was pretty fast. It was supposed to be. So for the reactor mode, you'll again compile it with the Fibonacci.wasm file. It did pretty much same stuff again on compiling, and then we use the reactor mode with the number 10, and we have the answer. Okay, that's cool. So we have sort of tried building WASM apps in Go and deploying WASM Edge apps in Kubernetes. Okay, so there are also things that we can do with WASM Edge, developing WASM Edge applications in Kubernetes. For this, we can use Docker or a lot of different toolings, it seems. This sounds exciting, but do we really want to do another demo? I think this demo was pretty cool for me to understand what different types of WASM Edge commands we have. I think I would love to see what other stuff we have in WASM Edge. So yeah, WASM Edge subcommands, options, and these things. So this is just a way I, in general, explore tools and new projects. And this is my first time going through WASM Edge, so I'm finding it pretty cool up till now, seeing how we build applications in TinyGo and hopefully soon in Go. So we have WASM Edge, there are subcommands and options, and there are tags and arguments. So the subcommands that currently exist are compile, which is the compiler subcommand, and run, which is the runtime tool subcommand. Okay, that's cool. I would want to know what is the difference between these two things. Okay, running with WASM Edge, the WASM Edge CLI. I think this is a pretty cool documentation where you get to know more about the WASM Edge CLI, WASM Edge Run CLI, the AOT compiler, and Docker. I would go with the WASM Edge CLI and check what things it has. So there are examples like building and running a standalone WASM WebAssembly application. Okay. So the Hello World example is a standalone Rust application. We just did something with Go language, so I think we're not gonna repeat it again. But I think it does something similar using a target WASM Edge, and it uses the enable all statistics. So we see these are the two subcommands, and there are a lot of application options here. The reactor one that we already used, and I hope you all were able to understand what initialize did when I said that initialize was basically thing that sets up the module before it starts handling the request. So if initialize is exported, it calls the module loading easily. Okay, I think that was what it was doing. The directory is binding directory into WASI virtual file system. Each directory can be specified as dir host path, and you can also map a guest directory to a host. Okay, these are simple options. There is a host option. No, this is not an option. This is just an extended version of what directory does. There's environment variables that we can add, enable instruction count, enable gas measuring, what it does, enable generating code for counting gas. Okay, I think these are pretty self-explanatory, the names of these options. Yeah, I guess I am pretty clear with what this does. Are there any questions that you all have or things that you would want me to go through next before I jump onto the next part of exploring WASM Edge? If not, okay, I think this was pretty cool. We sort of explored how WASM Edge fits in with different languages. So amongst all the other languages that it spoke about, like Rust and JavaScript and Python, C, C++, I chose Go, and we went across with TinyGo. I would love to next explore how WASM Edge applications are deployed in Kubernetes, because after all, this is a CNCF chat loop backoff, and we would want to see how WASM Edge fits into the cloud native ecosystem. So let's quickly check out how WASM Edge applications in Kubernetes works. So WASM could be integrated with existing cloud native infra seamlessly, so developers can leverage container tools like Kubernetes, Docker, and Cryo to deploy, manage, and run lightweight WebAssembly applications. This sounds kind of cool, but what next? With container shim, this seems like a lot of information. I would probably need my Docker running so I can quickly go through this. Okay, yeah, so we are sort of trying to see how we deploy WASM applications in Kubernetes, and in this chapter we should try to introduce how to deploy WASM using the existing container toolings. So the existing container toolings that WASM currently supports is Docker plus WASM, Podman, low-level runtime support, using WASM and Docker, high-level runtime support, LLM workloads, Kubernetes use cases. This sounds good. I would want to go with Docker plus WASM because who doesn't want to see how Docker thing works? So Docker announced in support for in partnership with WASM. Now we can use one single command, that is Docker compose up, to run WASM apps. That's kind of cool. So basically Docker is providing support for WASM, and that helps us with a lot of things. Cool. So let's refer to the quick start with the Docker part. Okay, we have a separate documentation for it, seems like it. Okay, so I would try this out because it's sort of really exciting me. And maybe after this demo, we can quickly go through the GitHub page because I love exploring the code base in general when I want to contribute to some projects. And okay, so the quick start with Docker. In this guide, we will walk you through how to quickly run WASM applications in Docker desktop. And there is no additional dependencies as the entire development and runtime environments are managed by Docker desktop. So it seems that WASM is very closely tied with Docker, and it makes things much more easier and fun for us to use. So we will cover the following stuff, like running a standalone WASM application, running an HTTP server. I think I'll quickly close my screen time. Yeah. So we will cover these things, that is running a standalone WASM app, an HTTP server, and a JavaScript server. Okay, I'm not sure about the JavaScript stuff. I'll have to probably install it or things. But I would start with the standalone WASM application. There are some prerequisites mentioned here. If you're interested in knowing how to build, publish, and compose WASM container apps from source code, check out the Docker plus WASM app chapter. Let's quickly see what it has to talk about. Docker distributes this and allows developers to build stuff in WASI. It's an empty with file without containers. In this guide, we will cover how to create a Rust program. So I think WASM containers are fully OCI compliant and hence can be managed by Docker Hub. These are cross-platform and can run on the OS CPU Docker supports. I don't know, I think this is something worth exploring, and I believe this is sort of describing how WASM's integration with Docker desktop is, which enables developers to build and share and run WASM-based containers inside a traditional Linux operating system or Linux-based OSs. Yeah, less for what we have to do with how we run Docker desktop. So I'll just go back to the previous guide and see what prerequisites we have to meet. You must have a Docker desktop of 4.15 plus installed. I think I do. I recently updated my Docker desktop. So make sure you have turned on the containerd image stored feature in Docker desktop. I think my Docker desktop is not running right now. I will have to open Docker desktop. Yeah, now and next we check how we run a standalone WASM application. So the Hello World example is a standalone Rust app. Okay, its source code and build instructions are available here. Let's check this out. What does this have for us? Hello WASM Edge. Please install the prerequisites first. Okay, it has a lot of these links that we have to go through before we get done. Rust examples for WASM Edge. The prerequisite is to install Docker Desktop that we have already, or you could install Rust and WASM Edge as follows. So this is an or. We already have Docker Desktop, so we wouldn't have to probably install WASM Edge if you are already having a Docker Desktop. That is the compatibility these two things have right now because of the partnership that Docker Desktop made with WASM. So these are standalone examples. I think we have already met the prerequisites, so I can close this tab. Hello, WASM Edge. You have installed the prerequisites, and let's talk about code then. Here's the standalone source code, and build instructions are here. Okay, so the source code is something we can explore from here. And the source code shows a standalone Rust application with main entry point. Compile the Rust source code project to a WASM bytecode file. Build and publish on Docker. Okay. Okay, this is more about the code stuff. I think I should go back to the quick start guide and see how we use Docker to run containerized WASM application. It's stored in Docker Hub and its image size is 500 KB. This image can run on any OS and CPU platform Docker supports. So let's try this out. This is, what is it going to do? It's basically going to run a containerized WASM application. Oh, sorry. This is the code that we want. I'll open my terminal again. Awesome. I will simply run this tool command. Oh, it's again a lot problematic. I think someone really needs to get here and fix these commands so that it can be easily copied. Yeah, this makes more sense. And I'll copy the docker run command. Come back here. Make this more shorter. There you go. So Docker run, and we're using the RM to remove something, runtime, container D, WASM Edge application, and then a second state Rust application container. Okay, unable to find image locally, and it'll probably fetch and start doing the stuff. We should probably get an output saying hello WASM Edge. To learn more about it, how to create WASM apps in Rust, you use these examples. I think the documentation is pretty extensive and it has a lot of resources in the documentation itself. That makes it much easier for me to go through it in the first time. Seems it failed. Why is it failing? So pulling it, operating system is not supported. Oh, that's a weird issue. You sure? Pulling from the second, the operating system is not supported. There was no information about the operating system. This image can run on any operating system and CPU platform that Docker supports. Okay, I think this is a simple Docker run command and it should be supporting. Running this. I'll try it again. The run command is a self-sufficient library. So I will run the Docker run command again. It's not copying. I'll copy the command again. Unable to find the library, this thing. Okay, so it's not working on here. I don't know why, but I think what this command was supposed to do was simply start a new container. And I think the RM flag here is just to automatically remove the container after it is stopping. But this seems to not even work this time. This should have worked. Previously it did. But the runtime IO container D WASM Edge is probably something that is specifying WASM Edge as the runtime instead of the default Docker runtime, which is usually something else like RUNC. but this time it did not supposed to work again. The Rust application is not here. Okay, let's move on to the next example, because when the code does not work during a demo, we don't play with it directly here. We only have 20 minutes left, so I would really want to go through this before I dive into the code base. Run an HTTP server. This example is a standalone HTTP server written in Rust. It demonstrates that Rust plus WASM Edge as a lightweight stack for microservices. Okay, so use Docker to pull container images. We're again using the run command, and the runtime equal to containerd wasmedge.io, and the platform is WASM, which is pretty evident by the name itself that this is telling Docker to run the container in a WebAssembly system interface. So basically, WASI is WebAssembly system interface, and that's what the platform is telling Docker to do. And what does WASM do? So let me check quickly what was. WASM workloads. Oh, it's still beta. We have some interesting examples here as well, which we can probably use if the Rust example is not working. So this is also another Rust example, which I would like to try out, because we're just going to do random stuff and see what crazy stuff we have here. Okay, unable to find image again. This operating system is not supported. Is there information about which operating system would be supported here? Okay, this has a lot of information. It's probably the Docker version that I'm using. Which version is this? It's 27.3. I think it's supposed to be, so I would probably. Oh, so it is 4.39 for the Docker desktop, and the Docker version does not seem correct to me, which is why this whole problem is coming. I will need to update my Docker, but we at least know what was the reason now. I think Docker is up to date with 4.39. This shouldn't be the reason. WASM Edge runtime is available. There is no problem here. Nevertheless, we have seen there was an example. So this library exists here, and there's a runtime. There are some flags. This looks good to me. Cool. So now I've understood this is still beta, which is yet to be stable now. That's something we've learned. Oh, yeah, this is my favorite thing when I explore projects, that is exploring the code base. I always come to the code base and just try to dive into what different parts of the program is doing. And this seems like the WASM Edge organization on GitHub, where we see a lot of repositories and a bunch of information about the contributors. So there are WASM Edge DB examples, WASM Edge logflex, and all these stuff. This is the public repository. And we have a lot of examples here as well. So there are plugins. What would that do? There are WASI plugins, compose signatures, logging, and this stuff. It's kind of cool. What does tool talk about? I would like to check out the plugins that WASM Edge currently have. There is a WASI crypto plugin, the HTTP one. I think we did not explore the HTTP one. We should sort of try this one out, but Docker is not working right now, so we cannot. I think Docker just did not work this time for us. Maybe it's time to try Linux. One-liner installation of WASM Edge for Linux. I would try this out. This seems about pretty much similar. Oh, I would love to check the frequently asked questions, because generally, if y'all don't have any questions, we can probably go through these. How it handles memory sharing between modules. It currently does not support shared memory between different modules. Each module has its own linear memory space. However, it is possible for pre-trained models to do things. What is the internal flow of model? Why is my plugin crashing? Oh, it's not yet. How to create a virtual machine? Can WASM support TensorFlow as its interference backend? How to read a host file in WASM Edge runtime? Oh, you can read a host file. For interacting with the host file, including the file operation, you can use WASI API to open and read files from the host system. That's pretty cool. So WASM Edge also offers a WASI API that we can use to read stuff. Provides the following built-in stuff. And there's a bunch of information. The documentation is pretty extensive. I would want to explore this more. You can extend. Oh, that's something really cool. So whenever there is a thing where you can extend stuff, it makes it much more cooler and fun for people to explore it, because extending WASM Edge is probably building your own stuff. So I think this section is moreover like an invitation for developers like us who would want to contribute to WASM Edge and probably build something which will evolve its use case. So this is more about it, and I would love to explore this further later on to see what different extensions maybe that I can create. I can sort of create something different. Let's see what are already there to help new contributors understand WASM Edge development workflow. This guide will include building the plugin from source on different platforms and these stuff. Ideas for contributions labeled with good first issues. Oh, these are just random stuff, but I think this pretty much makes it evident. You can extend WASM Edge. We have release processes, contributing guide, testing. It's still a work in progress. I think there's a huge scope of contributing to WASM Edge because there are a lot of things which are still out there yet to be written, and that makes a project much more fun to work on it from scratch. So this is a WASM Edge internal architecture, which looks really cool to me. It's an overview of our execution. So what it does, overview of WASM Edge execution flow and how it does things. So from what I see here, it's going for files or buffers. I think it's more over talking about the WASM Edge execution flow. Cool. It has a loader and creates WASM AST. So it seems like WASM Edge executes WASM flows modules using a structured pipeline like this one, and this execution pretty much follows a lot of things like we saw on the terminal, like a loader, validator, instantiator, and then there was an AOT section that is found. What exactly is AOT? So I would want to search what AOT is, which is not here, so that we can, I think I know the full form of it, but I'm not sure ahead of time. Was some WebAssembly stuff. Okay. What does AOT stand for? Oh, so it is the act of compiling an often high-level programming language into a lower language. Okay, that's what it is. So that's what WASM was doing this whole time. So we see there is an instantiator here, right over here, which creates the WASM instances, which in my opinion is doing is this instantiator is creating a runtime instance of the module and allocating memory, stack, and registered functions for it. So that's how the internal flow of WASM Edge works, and it's then executing the WASM module, which is pretty much clear from here. I think it's also interacting with the host and functions in the runtime, calling the host functions here, and accessing the runtime data. This looks kind of cool. I see. So it's pretty much evident from here that the types of host function calls that WASM Edge is making are sort of system calls that we see here, which system calls are like the file input output operations, which are process managements done directly through WASI, which is WebAssembly system interface. Then we can also see the WASI crypto calls here, which is basically secure operations via the WASI crypto, which we saw earlier in the code base of WASI. There are stack managers, runtime data management. These are socket-related function calls. I think socket-related function calls are more like networking via the WASM edge WASI socket. So these are some different types of host function calls that WASM's execution flow offers. And there is also a really cool memory management for stack and stuff, which you can see is done through memory manager. There is a stack manager and a registered module function manager. And I think this keeps track of all of those imported and exported functions. So this flow makes it very much clear of how WASM Edge is doing all the great stuff it is doing by simply loading WASM Edge at first or in the memory buffer, and then validating the WASM module, which is the validator is checking if the WASM module is following the WASM specifications like type safety or function signatures or all those things. And if the validation fails, probably the execution stops. And then it is instantiating stuff for WASM modules, which is more like we spoke about it. It creates a runtime instance of the module. And then ahead of time suction is found, where the instantiator creates a runtime instance of the module and then moves towards, if it is a yes, it goes to the EOT engine. If it is a no, it goes to the interpreter engine. And from there, we have WASM Edge executed. So executing the WASM Edge module is basically where we saw it runs the compiled or interpreted WASM code using the WASM Edge runtime. So that's the cool part of it. Do we have any questions? I think we have 10 minutes remaining.
And I'm back. We do not have any questions from the chat. So if anyone has any questions, please, this is your time to ask them. We have just a few more minutes left. And here we're back. I have to say that it was very interesting following you while you were exploring a new project.
Yeah, it was actually very interesting for me as well. Like WASM Edge is something so much trending right now. Whenever we go to KubeCons and we're always hearing about it. So it was my first time going through the project, and it has some really cool stuff. And I'm really excited about Go, support for Go. Whenever it adds it, I would definitely go and deploy some of my projects through WASM Edge.
Oh, that's very nice. Oh, we have a question. Let me show it. I don't know if you can see it, but the question is, can you run AI workload on these runtimes?
Oh, I think I did saw that somewhere. So I think WASM Edge does support running AI workloads, but that's by integrating AI inference engines through WASM. What was the extension name? I think it was WASM INN. Let me check. It's not here. Probably we go on the internet for it. It's probably WASI INN. Oh. No. Oh yeah, there you go. So this is something called the Neural Network Proposal for WASI, and I think this is an API for machine learning. So I guess it is designed for AI and machine learning, and how AI workloads basically run on WASM Edge is through this module, and you can use it if you're building applications and things like that. Oh, I think that was it. This is a repo worth exploring.
We have another comment, which is not a question, but it's a very nice tip. Actually, this will be used by me immediately. A tip on exploring GitHub repos. If you hit the dot on the keyboard while in the repo page, it will open up a VS Code environment with the source code.
Oh, really?
Yeah. Thank you, Charlie, for the comment. This looks very interesting.
Oh, okay. So it'll open GitHub code spaces?
Mm-hmm.
Oh, wow. This is something really cool. I did not know about this. But I could just imagine opening the terminal on VS Code. It directly opens code space. This is so cool. Thank you so much, Charlie. I would have used this maybe in the next time I'm doing it.
Yeah, me too. I'm a bit tired of just cloning every
Yeah.
GitHub repo to go through them thoroughly. This is very cool.
Yeah, exactly. This is so cool. I can actually go through everything directly from here. Oh wow, today I learned. I want to try this. I'm not sure. Do we have people in the audience who are already using WASM Edge and have some fun stuff about it to share with us?
Please
Hey,
share on
that
the
would be
chat.
Okay, so we have the whole code base here. This interface is so much more cooler. Oh wow, we have all these stuff. Oh, we have the WASM Edge AI support the running AI workloads on runtime. So this is WASI NN. And it has a couple of C++ code and others. It's using type commands and SPDX. Which language is WASM Edge written in? So it uses C++, C, CMake, Java, Python, and Shell. So people who are using these languages are probably on the go if they want to contribute to WASM Edge. And we should have more stuff here. So it's using Rust, WASM, Rust, JavaScript, and CUDA. That's cool. For contributors, I think there's a really cool contributor guide here, and WASM Edge is actively looking for contributors because it has a lot of areas for contribution. As we saw already on the documentation, a lot of pages were yet to be written, so you can anytime just hit the documentation, start contributing from anywhere. Oh wow, there's also here a develop WASM Edge plugin in Rust with WITC. I love such flows because it makes understanding things so much more easier. There you go.
Yeah.
I really enjoy it.
Sorry.
Yeah.
I could tell you were enjoying it, and I was betting with myself. I'm sure immediately after the event she's going to go and try that Docker that she wasn't able to find.
Oh yeah, exactly. It's probably the version, but no, not exactly it. My version was pretty compatible. I'll have to check. Maybe Docker is having a lot of problems with Mac OS these days. I was trying to figure that thing.
Well, I think we have just a bit more than 2 minutes left. So if anyone has any last minute questions, now it's the time. And Faika, I might ask you a question because while watching you, I got inspired as well. You said that you like to support different projects, right? To contribute to them. How do you usually go about it? Do you just see, okay, I like this project, it's so cool, I would like to contribute to it? Or is it something that you use every day and you contribute to make it more useful for your work?
Yeah, so I think most of the time it is the other, like the latter one. I in generally when I want to use something is when I go about exploring it, and if I find some areas where I see okay there is open area for contribution. Like right now when I was going through the documentation of WASM Edge, I was seeing so many more stuff like extending WASM Edge and then contributing to docs in there where there was stuff not written. Then there were so many execution flows that I was thinking on the top of my head, oh, this thing is not here, but maybe we can work on it. So the best thing about open source project is there is always an open door to contribute stuff. So I just think about the project that way, and while I'm exploring I find some areas and then I'm like, okay, I can probably go from here and contribute. That's how I've mostly found projects to contribute into.
That's great. And I think we don't have any more questions. We can just end the stream now. Thank you so much, Faika. This was an amazing walkthrough of WASM Edge. It makes me want to go and try it as well, even though I'm mostly an infrastructure girl. Yeah, thank you everyone for being here. And of course, these events are going to be recorded as well. Thank you, Faika.
Thank you so much, everyone.